So let's see. Gonna start with the new topic today. It's basically called deformation. So this is the last topic from like these forces and stuff. So let's have a look. So first of all, let's have a look. You have a string, all right? Let's draw three of the positions that the spring may have. So a spring can be basically of some original length. Suppose this one. Let's call this LO. And then if you basically pull it down with a force, the spring may extend a bit. So this will be its final length. Let's call this LF. And then a spring may also be compressed if you apply a force upwards. This would be the final length as well. Now, the first diagram basically shows you that the spring is at equilibrium, which means it is at a balanced position right there. Then this one basically shows that the spring is at, so it is in compression. And you can know this by just simply finding the extension x, which is basically LF, the final length minus the initial length. And remember, this is going to give you a negative value, because obviously in compression the initial length will be higher than the final length. Do you guys get it?
Yes.
Good. Now, the third position that you see is when it is at, you know, this is in tension. Tension means when something is pulled, it's basically causes tension in it. So the extension now, x, will be LF minus L naught. And this will give you a positive value. And this is how you will know that basically in tension, the final length will be higher than the initial length, like that. Right. Please let me know if you have a question here. Okay.
No.
Now, whenever you're gonna basically see tension force, wait a second. Oh, So the tension force is when an object is pulled outwards. Like you apply a force here, you apply a force here. So this will basically cause the object to get longer from this side and shorter from the other side. So basically the effective length would change like that. Volume just stays the same. So you guys need to remember that as well.
Can you please repeat that? Volume stays the same and
Yes, what I'm saying is that when something stretches, right, you might see that these two sides, which is this one and this one, this is gonna get longer, like it's gonna get stretched out. But with that stretching out, it is going to get shorter from other side. Do you understand?
yes.
Because you can't increase the number of particles. So generally, what you would see is that it will have the same volume, but it will extend from one side or one dimension. Okay, like
Yes.
that. So we can say tension force is a force that tends to extend an object like that. So you can write that. The next type of force we will be dealing in this one will be the compression force. So a compression force means that suppose you have an object like this. So what's going to happen if you apply forces inwards like this to compress it? One dimension is going to get shorter in length, but it's going to extend from the other ones. It's just that it is going to go like this. Like I said, you're applying force, so it's being compressed from one side, but it's going up from the other side, just like that. A compression force is a force that tends to push an object inwards. All right, to compress it. You can write that as well, please. And do let me know if you have any questions here. Right. Okay, please write this down so I can just go forward now. Interesting. Right. Now I'm gonna go to the next. All right. Um, यार बेटा ये जरा पंखा तो स्लो करो थोड़ा. नहीं स्लो कर दो. हाँ बस ठीक है बस सही. Okay. So now, when you apply a force and you cause an extension or decrease in length, which is compression, We can then look at the Hooke's law, and Hooke's law basically states that force is directly proportional to the change in length, which we call basically extension. You can write extension in the definition as well, doesn't really matter. This will give you 1 mark, but the second mark basically starts from here. So I'm putting these 1 and 2. You don't have to write it, please, just to tell you what to write. So proportional to change in length extension, unless limit of proportionality has not reached. So remember that the notation of extension, I'm going to explain what it means by the way, is E or delta X. Sometimes they also write X, it's all right. Okay, so whatever they give you, don't worry about that. It's just the same thing. Okay? So basically, what the Hooke's law states is that the force is proportional to the extension, directly proportional, by the way. So when you remove this sign, it's going to give you F equals to kx, like that. This k that you see is known as the spring constant. Spring constant basically means that it's the force acting per unit extension. So K will be F upon X. The SI units for this is newtons per meter, right? The most important thing that you guys need to know is, you might not have known this before. Basically, spring constant shows the stiffness of a spring. Now, what exactly is stiffness? Stiffness basically means that how hard it is for a material to show extension for a set amount of force. Do you guys get it? So stiffer spring would be harder for you to, extend rather than a softer spring. Get it? Anyone who has a question, please let me know here. Okay. Furkan, why are you late?
Sir, wait, stiffer spring would be harder to stretch, right?
Yes,
Okay.
exactly.
I thought I heard you say easier.
No, no, a softer spring is easier. Like, if you take out the spring from your ball point, you just pull it a little bit, it just gets deformed permanently because it's so soft, right? But the
Yeah.
spring that is in your car or maybe, some other big machinery, that doesn't really extend or
Okay.
compress that easily. That's correct. Now, stiffness, basically spring constant, really depends on how the spring is made, right? So what is the mass of the spring? What is the volume? And depends on so many things, density and stuff. But that we do not need to know. We just need to know that the greater the spring constant is, the value of it, the stiffer the spring would be. Understood?
Yes.
Now, I just want to tell you, I basically tell my IGCSE kids about this. But I want to tell you so that you guys have a clear concept. And I don't know if you have that, but I'm going to just quickly write few things here. So in physics, you will basically see three types of relationships very often, right? They're going to talk about that. So this is basically not required, by the way. If you do not want to write it, so it's okay, just for your information. Um, So the three different relationships they're going to talk about would be directly proportional. They're going to talk about just proportional, and then they might also talk about inversely proportional. All right, so these are the three words you're going to often hear in physics. So suppose there's a quantity y and x, and we're building a relationship around them. So directly proportional means that the graph line is going to start from the origin always, like 0 and 0, and it would be a straight line, right? So this is something that you guys need to remember. So it is going to be a straight line and starts from origin. So automatically, if something says directly proportional, you should remember that. Then just proportional means that it's gonna have to start from some y-intercept. Okay, so it will just be a straight line, and it will have a non-zero y-intercept. Sorry for the small writing. So generally, the equation that we use for, in fact, all the time, this will be y equals to mx. This is the equation in math. This is basically y equals to mx plus c. And inversely proportional would be a line like this. It will be a downward curve, by the way. So it's basically, it curves downward, right? Always. And the equation that we use for this one is y equals to 1 upon x. Do you guys understand that?
Yes.
So whenever they use a certain word in their definitions, you should remember that. Okay, that what they're asking you or telling you. For instance, if you look at this definition, it clearly says that force is directly proportional. So it means that the diagram between, or the graph between force and x is going to be like the first one. Get it?
Yes.
All right, that's very good. Now, generally speaking, I found this chapter to be easier, like one of the most easiest chapters in the whole AS. It's very linear, just a few formulas, and you will be done with this. So, if you allow me, I would like to go forward now. If you guys have written all of this. So now I'm going to the next part of the definition. So I've told you what exactly directly proportional means, and now we're gonna go towards unless limit of proportionality is not reached. What does that mean? So when you draw the graph of this, like I said, now there will be basically two basic graphs that we need to learn. All right. The first graph is between force and extension. And the same graph can also be given with the flipped axis, which means extension on the y-axis and force on the x-axis. So what will happen? Nothing really will happen. It starts with 0 and 0, like I said. It's a directly proportional graph. But at one point, this graph is going to get curved a bit. Now, the point where it gets curved is basically called the limit of proportionality. This is what basically the point is. Limit of proportionality basically means this is a point beyond which Hooke's law is not obeyed. All right, which means force does not stay proportional to extension. The other thing is that you might notice that the line basically curves towards the x, wherever the extension is, that's where it is going to curve. Now, most of people, what they do, what mistake they do is they bring it down. It doesn't come down, it doesn't go up, it just slightly bends. Is it clear, everyone? Slightly bends. So you got to remember that. So please write this down so you guys have a clear idea about that as well. Right. Abdullah, to know where the limit is, we have an experiment that we're going to do. Experimentally, we know that now force is not proportional to extension, but we're going to do in a bit, okay? But for now, you need to remember as soon as the line does not stay a straight line, the point where it starts to curve would be the point that is limit of proportionality. You get it? But all of these curves, everything is done through an experiment. We're going to do that. Don't worry about that. Now, if they give you a graph of extension and force, then what you do? You start with the origin always, but this time the only difference between this and this is that now the graph is going to curve upwards. And why it is curving upwards? Because extension is there. Wherever the extension would be, it would just slightly curve towards there after limit of proportionality. Get it? Good. Yes, Shazib, you have any questions? Zeruba, about you. Farina, Fatma, Imal, Asma, any questions? Okay.
No, sir.
Dania, everything is clear. Okay, good.
Yes.
Furkan, what about you?
Yes, sir, it's clear.
Yeah, it's basically most of it is like O level stuff that we have already done. Well, it's good. Now let's do a question, okay, from here. And you guys gonna do that, and then we're gonna go forward. For example, it says a spring is loaded with 5 kilogram of mass if the extension is 2.0 millimeters. Calculate the spring constant. Can you guys please help me do this? Okay, let me change it a bit or elaborate. Spring constant in Newton per meter. Okay, this is what you would do. Can you quickly do this, please?
So I got 25,000 Newton meters.
25,000 Newton meter. That is absolutely correct. That's correct. Very good, Imam. Who could not do this? Can you please tell? You guys please try this. It's not very hard. Okay. Now, if you load something with a mass, obviously the mass will have its weight acting as a force, which means the mass was 5, you got to multiply it with 9.81, right? This should give you about 49.1 newtons. So this should be the load. You got to change the extension into meters because obviously it should not be in millimeters if you need the final answers in meters. Then what you do is you apply F equals to kx, and k will be equal to 49.1 divided by 0.0020, which should give you about 2.5 into 10 raised to power 4 Newton per meter. Please check. Very simple. Nothing,
Yes.
extraordinary here. Yeah. Okay. Now, interestingly, on the same diagram, I want to tell you two more things. If you try to find the gradient of, this line, so you're going to get change in f over change in x, all right? So the gradient of the above graph, its force and extension would be equal to k because that would give you force of extension like that. If you find the gradient of this graph like that, then basically it's going to give you change in x over change in f. Do not be alarmed. It is just basically 1 upon k because k is force or extension. You guys get it? So it really depends what gradient you're looking at when you're finding it from the graph. So you can basically add that in your graph. So that would be good. Okay. Done. Should I go forward, everyone?
Yes.
So now we need to learn, like you guys asked me, how do you find, uh, you know, limited proportionality, whatever. It's basically done through an experiment. So we'll do an experiment to find
So
spring.
is this a practical experiment in paper 3?
No, it's not like that. It can, like the experiment, this sort of experiment can also come in the paper too, right? But that is different. That is different. Okay. I think we can keep one day. On Saturday, I sent you the link. Nobody came for the class. That's very bad, by the way. I told you I will take your class.
So I had another class.
I waited whole 15 minutes and then I closed the meeting because you guys did not show up. That's very bad, actually. Anyway, so one day we'll keep a class and I explain you paper 3 and how to, properly do that. But unfortunately, you need to attend your school lab classes all the time because to be, accustomed to how you can set up the operators and stuff like that, you guys need to learn that. But for the working part, I can teach you right here. Anyway, I'll do that soon. So what you're going to do in this experiment is you're going to put a stand. So those who have done experiments at school, they might already know. Stand looks like this, right? Then what you do is you connect, this is called a boss. Boss is basically held up against the stand. and then you need a clamp like this, which basically the function of a clamp is to secure something, right? So there's a clamp like that, and you got to basically put a spring that you're basically experimenting on like that, and on that spring you need to put a mass hanger. Mass hanger looks like this, by the way. Then from another clamp or maybe another stand, doesn't really matter, you're gonna basically clamp up a ruler. Show you a ruler like this. So this way you're gonna put a meter rule like that. All right. So just I'm gonna just label this. This is your stand. This is boss. This is your clamp. This is meter rule. This is the spring, and that would be your mass hanger. It's called mass hanger. Okay. So mass hanger, what it does is every time you're gonna add a mass on it, the spring is going to extend even more, and then you can take the reading on the ruler. Do you guys understand that? These are basically called, if you don't remember, this is basically called slotted masses. Your practical teacher might have told you this, all right? Now we're going to basically learn how it's done. First of all, in paper 2, they can ask you about the explanation, but then they don't want you to make a graph or table. Sometimes they give you a built-in graph you need to read, or sometimes you might have to make a graph, but that's very unusual though. So length of unloaded means when you have not put any slotted masses in the mass hanger. Unloaded spring is measured using a meter rule. All right, so this is the first point. Let's call this LO. Then slotted masses are added of various values in to increment the load. All right, incrementing the load means that you keep on, like, you add like 100 grams, then you add another 100, then you add another 100, like that, right? Measure the new length at each increment, and let's call this LF, like that. Okay. This is by the way, sometimes the examiner would use the word loaded length, but that's the same thing, because loaded length basically means that when you have add loads and you're finding the new length, all right, like that. Finally, you guys need to draw a table. So first you basically put this, and I'm going to tell you what to do next. Now, in this table, you will have certain values like, let's go to the next page. You can write this down, then I'm going to go forward. All right. All right, kids. So now, when you draw the table should look like this. So generally, it's a good practice. I'm just gonna show you what to do. Even in the practical exam, you got a first column should be of serial number, where you got to take 6 set of readings. All right. Then write what is the mass you've taken. Okay, I should have drawn a bigger table. Chalo, never mind. Or should I make it bigger? I don't know. Let's make it bigger. Resize, please. Okay, what? Oh no, that's not good. That's not good, kids. Wait, let's make it a bigger table. Okay, like that. So first of all, the first is the mass in kilograms. All right, so you do that. So this is the mass you're adding. Then you find the force in newtons. How do you do that? Just multiply mg like that. Then the next you got to do is you got to basically put the unloaded length. This is L naught. Yes. Phone आ रहा है. Okay. Hello. Hmm. 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 नहीं. Jeans and shirt. Yes. Okay, so the loaded length will be like this, right? So you got to basically take these, and then you have to have another column. Sorry, that I failed to draw. Okay, so for this one, I just want to tell you, you need to have extension. The extension will be basically taken in final length minus the unloaded length, right? So this will be in meters. This will also be in meters. This will also be in meters, and everything else is in newtons and kgs, right? Do you guys get it?
Yes.
Yeah. So you can draw this. And once you've drawn this, you got to plot a graph. Plot a graph of best fit, where F will be on y-axis and extension x on x-axis, right? So you can do that. Now, when you draw the graph, I just want to tell you this very important part, that this graph that you have must start from origin, by the way. And you might have different points, like you might have points like this, like this, like this, like this, like this, like this. Best fit line basically means that this is a best fit because there's some features to best fit line. Now, the best fit line means that equal points above or below and below, sorry, and below. And the other feature should be that it must be close to all points. Now, the biggest misconception that people have about this best fit is that they tell you that best fit is a line which basically connects with most of the points, and then there are equal points above below. There is no such rule as connecting it with most of the points. Even if none of the points come on the line, but they're equally divided above and below the line, then it is called best fit. Is it clear to everyone?
Yes.
Yep, it's good. So we've drawn the best field line. You can draw this as well, please. And then we're gonna basically go forward from here.
Sir, does it always have to go through the origin?
Yes, because it's a direct relationship. Okay, Mal. And whenever you're dealing with a direct relationship, direct proportionality, so the line must always start from the origin. There is no doubt in that. Okay. Now, basically, you can find the gradient. So the gradient of line will give you change in f over change in x, which is k, the spring constant. This is how you can find the spring constant. You can keep on adding masses to know where the limit proportionality is, all right, Abdullah, where it will start to bend, but that's all right. Okay. Just note here that line must always go through origin in this experiment. It might be different from other experiments, but for Hooke's law, this is very, very important to understand that it must go through origin. Understood?
Yes, sir.
Okay, please write this down. Then we're going to go forward.
Sir, do you have a compiled PDF for all the experiments we need to know, like the procedures?
For paper 3, mm, no, because in my school where I teach, all right, I have a book made. We actually follow like different sort of experiments, but that really depends. I don't know if it's going to help you or not, but I'm going to take one of the books from the kids, which I've checked, and I'm going to share it with you so you can see what mistakes are there. All right?
Okay, sir, thank you.
Yeah. I can't give you the combined PDF of that because every school will have different set of equipment in their lab, right? So they plan the experiments according to that. Okay. All right. All right. I'm going to go forward now. The last thing we're going to do today would be basically the graph between force in newtons versus the length of spring. Now, this is a bit of a different experiment, different graph. So, in this sort of graph, they will generally give you, so don't be alarmed about this when you see this kind of graph. They will give you length on this side, that can be on the other side as well, by the way, it doesn't matter, and force in newtons of this side. Generally, it's like that. This basically graph starts from a y-intercept. It doesn't start from origin. And the reason is this is not an extension graph. This is a basically length graph, which means that this shows you very two important factors. So from this point to this point, this basically shows you the unloaded length. It means when you have not put any force, then what was the length of the spring? And after that, when the line starts to go, right? So after that, whatever that is, this basically shows you the change in length delta x due to load. So as you increase the load, obviously the length increases. So if you really want to know which what is the unloaded length of any graph? You just look at this point, whatever that says would be the unloaded length. Do you guys get it?
Yes.
Good. Write this down then, please. All right. Okay, so this week I think we're gonna we will be able to finish this chapter and its worksheet, and then we're only left with waves and electricity and nuclear physics. I think so. 3 units, which means by I think we will be finished by the syllabus in about mid of December to be safe, or even before that. Don't know about that. Much before that. So I think in your midterms, that's going to happen in December probably. So this is the chapter they're going to give you. So all of that before this and this chapter. So I think you guys will be covered most of it, and then we can prepare for your midterm right before your exams when we finish the syllabus as well. All right. So I think this would be all for today. Then tomorrow we are going to do quite a different thing. Then have a nice day. Then
Okay. Thank you, sir.
bye.
Thank you so much.